Alright, so today we are going to work on parabolas, which we might have gotten to a little bit yesterday. I'm making this video earlier in the week, so I'm not exactly sure how much we will have gotten to of this yet, so I'm going to break this down into multiple videos. And you guys will have all of those to look at as you're sitting in class on Friday. Please be nice to the substitute teacher today. I'm begging you. So, we're going to start out here. I'm going to do this with a few of the conic sections that we learned. We are going to derive where the equation for a parabola comes from. So, the way that I'm going to do this is I'm going to draw a picture of a parabola for you. And we're going to go back to some things that we learned in geometry. And then we're going to derive the formula. So, you guys have worked with parabolas earlier in the year, so we already know what a parabola looks like, but we're going to do a little bit more complicated stuff with it here and talk about how it relates to being a conic section. So, I'm going to go ahead and I'm going to draw a parabola here. And you know that a parabola looks like this, but what you don't know is what's special about a parabola is every parabola, if you pick a point on the parabola, there's a relationship between that point and two other things that go along with the parabola. One of them is called the focus, and the other one is called the directrix. So, I'm going to go ahead, we will call this point the vertex of our parabola. You guys already know that. But there's actually a point inside of the parabola called the focus, and there is a line the exact same distance away from the vertex, but in the other direction on the outside of the curve, called the directrix. Okay? So, again, this point right here is called the focus. And this line right here is called the directrix. And let's get a few things labeled here on this parabola so we can derive this equation. If this is the vertex, the focus is always p units away from the vertex. So, if I start at 0, 0 and I go p units up, this focus is going to be at the point 0 for x and p for y. Okay? If I go down p units from the origin, 0, 0, to get to the directrix, this is a horizontal line, and if it's p units away from 0, 0, it will be the line exactly y equals negative p. Now, keep in mind, the vertex here is at the origin, so if we started shifting around the vertex, the equation of the coordinates of the focus and the equation of the directrix would not simply be 0p and y equals negative p. They would be something different depending on where the original vertex is at. Okay? But for simplicity purposes, we are going to start it at the vertex at 0, 0, so we can keep these points, the point right here in this equation for this line right here, pretty simple. Okay? And I'm going to call this point over here along the parabola, I'm just going to call it xy. Okay? And what is special about a parabola is, in a perfectly drawn parabola, which this one is not, if you take the distance from this point xy to this focus, so that distance right there, it will always be the exact same as the distance from that point straight down to the directrix. And as you can see, this is not perfectly drawn because obviously those distances are not the exact same. But if it was perfectly drawn, this distance right here and this distance right here would be the exact same. Okay? So the way that we're going to derive this formula is we're going to go back to geometry and we're going to think about this thing called the distance formula. So you've probably forgotten this because we don't usually remember things for longer than about 3 seconds these days. So here's the equation, here's the distance formula. Okay, the distance formula says that the distance from one point to another point can be described with this equation: the square root of x1 minus x2 squared plus, square root longer, y2 minus y1 squared, and that is equal to d, we'll call that distance. Okay? So we're going to use that equation to help us derive the equation for a parabola. So here's how this works. If I take this point xy and I say, hey, what's the distance from xy over here to this focus, I have an x1 and a y1, and then I have an x2 and a y2. So if I plug this stuff in, I'll come down here and I'll do this on the bottom. If I'm plugging this in, here's what this would look like. Okay, x1, call x, minus x2, 0, we'll call that squared, plus y1, which would just be y, minus y2, which is p squared, is equal to the distance, because remember these are the same, this and this, okay? So this right here represents the distance from xy to 0p. That distance needs to be the exact same as the distance from xy, this point, straight down to this directrix, okay? Now this is always confusing for people, so stick with me here. The distance from the x-axis up here to this point, this is a vertical distance, that is a y value, is just y. Okay, so what's going on here is y. And the distance from right here, p units away down to this directrix, is p. So if I take this distance y, and I add this distance p, I get the entire distance from this point right here down here to this directrix. Okay? So I'm going to do some simplifying here. Try and stick with me. Okay, we've got the square root. Okay, now keep in mind, if I do x minus 0 squared, that is just x squared. Okay, and then on the other side, if I expand out y minus p squared, here's what it looks like: y minus p times y minus p. And if I do that, it looks like y squared minus 2py plus p squared. Okay. Now, if I want to get rid of this square root, what I need to do is I need to square both sides of the equation. So if I square both sides of the equation, this stays the same. It would still look like x squared plus y squared minus 2py plus p squared. But if I square this other side, then this will look like y plus p times y plus p. And if I expand that out, I will get y squared plus 2py plus p squared. Okay, now what I'm going to try to do here is I'm going to isolate x squared. If you look at this a little more closely, you will notice that the y squareds on both sides cancel each other out, as do the p squareds on this side and the p squared on this side. So all of that goes away. The only other thing that I need to do to isolate x squared is I need to add 2py to both sides of the equation. So what this will look like when we are done is, switch back to black here, x squared equals 2py plus 2py gives me 4py. Okay, and what I want you to focus on here is this 4p. Okay, that 4p will be consistent in any parabola, and we have just proven where it comes from. So next time you are wondering where it's at, you can come back and you can look at this proof, and you know every single parabola will have this 4p. I'll talk a little bit more about what that value p means in a little bit, but what I want you to know is that every parabola will have a 4p right here in its equation. Okay. Now, what I have right here is a parabola that opens up. We talked about yesterday that there is also a parabola that can either open to the left or to the right. So I'm not going to go through this process again, but I am going to draw for you what that would look like. So I'll come over here. Let's pick a parabola that opens to the right. Maybe something that looks like this. Okay. Similar to what I did on the last one, if we call the vertex 0, 0, the focus is always on the inside. Okay. This time, instead of going p units up, we went p units to the right, so we would call this point P0. And then the directrix is always on the outside of the curve. It's P units away. So if I come over here and I draw the directrix, again, this distance and this distance is the exact same. Okay? But remember, the directrix is a line, and in this case it's a vertical line, so it is going to be x equals, because every vertical line is an x equals, and if I start at 0, 0 and I go p units to the left, I get x equals negative p. If I pick a point along this parabola, let's call this point right here, let's consider it xy. Okay. If I pick xy and I did a similar process, what I would end up with is, instead of having an x squared at the end of my process, I would have a y squared, and instead of it being equal to 4p times y, this time it would be 4p times x. If you are super bored, you could go through and you could prove that you would get this 4p right here, but what I'm trying to tell you is that every single time that you have a parabola, you will always have a 4p out here in front, okay? And one thing to keep in mind is if it's an x squared, like on this previous problem, it is going to be a parabola that either opens up, opens down, and if it is a y squared like this problem, it will either be a parabola that opens to the right or opens to the left.